Let's focus more on chromatography. This is the common technique that's used to separate mixtures of compounds so we can analyze and determine exactly what's present in that mixture. We're going to focus on high performance liquid chromatography and gas chromatography in a little bit. These are two of the most common techniques that you see used in analyzing cannabis products. But first, I want to give us some chromatography fundamentals. This will be helpful for our lab this week as well as we do a chromatography experiment. Chromatography is going to use the intermolecular forces of the different compounds in a mixture to separate them. So each compound, if it is a different chemical structure, should have different intermolecular forces. Even subtle changes between structures will produce changes in those intermolecular forces that exist between molecules. And so chromatography is going to separate samples out based on those intermolecular forces, which means we're really separating things based on how they dissolve in other compounds and how they interact with other compounds without bonding or without breaking bonds or without breaking the molecule apart. So the sample will be whatever it is that needs to be analyzed. It's the mixture. And we're going to give that mixture the opportunity to interact through intermolecular forces with one of two things. It can interact with a mobile phase, which will be usually a liquid or a gas solvent that's moving through the chromatography apparatus. Or it could interact with a stationary phase, which will be present in the apparatus, usually in a column, and it'll be solid and it won't move. And so we usually have our mobile phase and our stationary phase be made of compounds that are different in their polarity or different in their total intermolecular forces that they kind of have with itself. And so that way, any compound in the mixture will probably prefer to interact with one or the other to more or less of a degree. And how they interact with the mobile and stationary phase will be fundamentally different for each compound. And so that's how we're going to separate them. The mobile phase is going to be moving through the stationary phase. And so if something is very attracted to that mobile phase, it'll be carried through quickly with it. And if something is very attracted to and interacts very strongly with the stationary phase, it'll try to stay in one position with the solid, but there'll be a flow of mobile phase over it. And so that will force it to move it along, but its interactions with the stationary phase will slow it down. And so we would be able to separate them by having the one that was more attracted to that mobile phase separate out and come out of the instrument first, and then the one that was more attracted to the stationary phase come out second. So there's a few different types of chromatography, and I'm going to just show kind of like the three kind of main categories. One is thin layer chromatography, where we are putting our mixture onto usually a plate, and then we allow the solvent to move up the plate and separate out our compounds. This is also paper chromatography. We're going to use chromatography paper in our lab, and we'll do this style. It's the most accessible and the fastest. And so what we have is a stationary phase that will be the chromatography paper. We have chromatography paper that we're going to be using, but then you could also use something called a TLC plate, a thin layer chromatography plate, where it's basically like a little sheet of plastic, little rectangle, and it's coated in silica gel. And so there's a fine layer of silica gel deposited onto it. And so you're actually performing the stationary phase that is the silica gel. So there's a couple of different things that this could be. And so that kind of gives you a lot of flexibility depending on what it is you're trying to separate. So our stationary phase is the paper. And our mobile phase is a solvent that's a liquid. And we can choose a solvent or a solvent system. It could be a mixture of solvents um, to try to maximize the separation that we have between our compounds. And so different solvents will do a better or worse job of separating compounds really based on the compound's polarity and the solvent's polarity. And so in these chromatography experiments, usually there's a lot of work that's put into deciding what the mobile phase should be and what is the exact composition of it. And what happens in this one is through capillary action, the solvent, which I'm going to try to I'll grab a yellow, the solvent. So the mobile phase is down low. It's going to move up the paper. And if we place our mixtures down here, the bottom, just above the solvent line, as the solvent moves up, wicks up the paper, it'll carry our compounds with it. And how quickly our compounds travel up will depend on how well it is interacting with the mobile phase versus how well it's interacting with the stationary phase. Right, so these will all have that same principle of our compounds interacting with a mobile and a stationary phase, just kind of in a different format. So liquid chromatography is usually thought of as column chromatography, but this is also what HPLC is. So I'll start with the kind of the fundamentals. So in this case, we usually have a tube, and in the tube, we have a stationary phase that's kind of placed within it. And usually this is just going to be like pouring in silica gel. Um, or sometimes there are these special little tiny beads you can buy that are coated with a specific compound to give you a different type of stationary phase. But silica gel is the most common. So you'll have a stationary phase, and then you will apply your sample to the top, whereas here we applied our sample at the bottom of a piece of paper and the liquid flowed up it. We're going to start it at the top and we're going to have our mobile phase flow down through it. And so our solvent will be our mobile phase. And it's going to flow through the stationary phase and out the bottom. And so it's really letting gravity do the work of bringing the liquid through the solid stationary phase. And as it goes down through it, the sample mixture will separate out as some of the compounds are more attracted to the mobile phase and others more attracted to the stationary phase. And that'll change the amount of time it takes them to move through this column with gravity's help. Now, that's liquid chromatography. HPLC is the same thing, except it's under pressure. So it goes a lot faster. And so if we pressurize this system and we force that solvent through at a faster rate and in a more controlled, consistent rate, then this whole process goes a lot faster. Just liquid chromatography, if we had a nice long column. So the longer your column, the better the separation between your compounds. It can take hours and hours and hours and hours. And so HPLC is a way to keep that ability to really separate compounds, but to speed up the process. Then we have gas chromatography. Now, gas chromatography uses a column just like liquid chromatography, but it is much thinner and much longer. And so it's actually just like a tiny tube. And it's usually, I just showed one coil here, but it's lots and lots and lots of coils usually within the instrument. And here our stationary phase is in that coiled up column. And it's usually beads of a compound or a coating on the tube for the column of a compound that creates the stationary phase. And then our mobile phase is going to be an inert gas. An inert gas would be something like argon or nitrogen, something that doesn't interact with a lot of things. And so we'll have an inert gas, a gas flow through this long column. And then our sample will be injected and vaporized. And so our sample will now be a gas, and it will be flowing through a very long, thin column that's coated or has beads that are coated with a specific compound to make it either polar or nonpolar. And it'll flow through that column with inert gas as the mobile phase that's like pushing it through. And so it's very unlikely that our vaporized sample will interact much with the mobile phase, but it'll move it through that long column. And everything will be separated out by how well or not well it interacts with that stationary phase. But also, since everything is going to be a gas, the heavier particles will move slower than the lighter particles. And so just the mass of our compounds will also impact its ability to separate through the course of that long tube. And then it goes to a detector and we see which compounds come out first through that. And so all three of these kind of styles of chromatography will require a form of detecting our samples once we've separated them. And there's a lot of different styles for that. Mass spectroscopy is kind of one of the likely ones that we use a lot, or UV-vis spectroscopy or flame ionization detection. But we're going to focus on this piece here of chromatography because it pairs very nicely with everything that we've been learning about extraction and forming solutions and the intermolecular forces that really guide that process and allow us to make predictions and to design extractions to maximize the compounds that we really want to isolate.